Hello, class CSC 380 and Professor Gemmell. This is Daniel Bazan from Artificial Intelligence. Today I'll be presenting my dance battle execution simulation. So we're going to start off by running the executable. Here we have the option of choosing either 2 moves, 5 moves, or 10 moves. These correspond to the text cases that were given to us by Professor Gemmell. So for starters, let's run 2 moves. We select it using the radio button and we run simulation. The first set of lines is taken directly from the text case file. So we parse for the moves allowed and the tours taken, as well as the moves used by each of the players. Here, this 2x2 set of numbers here is our game board, which tells us which moves were used. 1 means that the move was used, 0 means that it was not. Prints out the player's turn, and then for that player, how many moves he or she is able to move, and the move combinations. Finally, it prints out the player's move that he or she has taken, and then do the same thing for player 2. Once the simulation is done, the dance battle simulation prints out the entire summary of the moves, all the moves taken, the number of moves that were taken, and then finally the winner. We can also use this button here, restart, in order to reset the entire project, and we can then choose a different simulation, this time for 5 moves. Same concept, it's a little bit longer obviously. Anyway, the dance battle model, here we start at line 102, where we run our while loop. The game state is a boolean, we keep running as long as it's true. Last second move is the move made by the first player. Since the rule is that the second move always has to be the first move, we set that last move to the first move. Then we run this function here, the move, to print out our current game state board, which is over here. It checks to see each of the move arrays, zeros and ones, to see which moves were taken or not. And then once we go through all that, we get to about line 290 over here, line 296, where it checks to see if this set of moves was not made, then we add it to our move array. So basically here, the DePaul model is an n by n 2-dimensional array, and it holds the x and y coordinates of the moves that are made. So for example, if player 1 made moves 2, 1, then we would add 2, 1. We would add the number 1 at the coordinate 2, 1 to show that the move is actually already used. Since we also have to, we also have to check to see if the same moves were used already, but in the reverse order. So for example, 1, 2, we also have to check that off, which is over here. Now we're going to talk about the min-max algorithm that I've written. Doesn't exactly work as the way I want it to be, since it doesn't always show the most optimal solution. But for the most part, we start out with how many of the second moves that we can make based on our situation, and this array holds each of the number of zeros in each of the rows. First, we check to see how many zeros are in each row meaning the first, the second move that's available. So for example, if the player has available moves 4, 1, and 4, 2, we would have to check rows 1 and 2 to see how many zeros that they have, meaning that the more zeros they have, the less likely we want to go there. The less likely the move we want to go there. So for example, for move 4, 1, row 1 would have 2 zeros, and then row 2 would have 3 zeros. We would obviously pick row 1 because it would have less moves, meaning that the player would have less chance, or have a bigger chance of filling up. The second player would have a bigger chance of filling up that rest of the row. So once we found the zeros, we add the zero count to the 0, and this temp sec is actually the kind of determines the that row and then how many zeros it has. Once we get all that, we check each of the zero array. We check to see which one's the lowest. Which one's the lowest count, because we want to fill up all the rows as fast as possible. Once we figure out which row it is, we set that row as our official second move, and then we would make the move, which we already kind of went over when I talked about my dance battle model. So we basically said the first move, which is the last player's turn's second move, along with the second move just made by the new player, and we went into this move array over here. And then we would print out the string saying that the player executed this move, and then eventually we would end the turn and then set the new turn for player 1 and 2. In case of a player running out of moves, we have this set over here. If there's no moves available for the player, we print out none, and then we set the game state to false. We declare the winner based on whose turn it is. Also, if there's a chance in which the player made an illegal move, for some reason this test did not completely pass, we would set the game state to false, and then we would say over here, if it was already false, then we would say that the illegal move was made by the player, and all that gets finally printed out in the solution function over here. We print out the summary of the dance battle, how many moves were taken by the combination of the player 1 and 2, and then our eventual winner. So if you guys have any questions or comments, feel free to leave on the page. So thank you.